Okay, so I want to talk about this concept of even and odd functions. Okay, I want us to get in the mindset of reflections. Okay, so let me just make sure I'm sharing the correct screen. Yes, I am. Okay. Now, if you look below this dotted line here, this is what we're focused on. Okay, and we're focused on A here. Okay, now this is the graph of A that you see right here. Okay, this is the graph of A. It's a parabola. Now, basically, if you reflect one side of a graph, let's use this side, if you reflect it over the y-axis and you get the same thing, then that's an even function. Okay? Let me show you another even function. Okay? Here's another even function. Look at this red. It's not going to be the best drawing. Okay, that's like a curvy W. If you reflect this portion right here, if you reflect that portion across the y-axis to the left, or vice versa, you will get the same graph. That's an even function. Okay, that's an even function. All right. Same thing with this green graph. Okay, same thing with this green graph. If you reflect this, that's like a curvy M, like mother. Okay, if you reflect it across the y-axis, you will get the same graph. Okay, if you reflect this side across the y-axis to the right side, or vice versa, you'll get the same graph. That's an even function. Okay. Now, odd function, you have to do two reflections. Okay. This is an odd function because if you reflect it across the y and then across the x, then you will get this. Then you will get the same thing. Okay. All right. That's an odd function. Okay. So here is also an odd function. Okay. Let me draw a blue one. So if you reflect it across the y and across the x, okay, and you get the same thing, then that is an odd function. So let's say your function looks something like this. Let's see if I can. Oh, let's start easy. What about just a straight up line? Okay, that is an odd function because if you reflect it across the y-axis, you get this red. Okay, and if you reflect this red over the x-axis, you get that red. So that's an odd function. Okay, this is also an odd function if it looks like this. Okay, this is also an odd function if it looks like this. Okay, that's not the best drawing, but you get my point. Okay, this is also an odd function if you get something like this. So I reflect it and you get that. That's an odd function too. Okay, those are all odd functions. Okay, let's do one right here. This is an odd function. If you get boom, okay, that's an odd function. Okay, so odd and even functions are easy to figure out graphically. Okay, graphically they're super easy to figure out. Now when you do it algebraically, that's where it gets, I wouldn't even say it's tricky. You just got to pay attention to what I'm going to say. Okay, so Let's clean this up. All right. Now let's look right here. I want everyone to pay attention to this yellow box right here. This is the most important thing for algebraic even odd functions. So let's pick a point here. Wouldn't you agree that this is maybe, well, no, it's not maybe, it is 2 comma 4. Okay. And if it's 2 comma 4 here, that means it's negative 2 comma 4 here. All right. So the key point is whenever you plug in a negative x, see, here's a positive x, a positive 2. And then when you plug in a negative x, you should get the same y. Okay? You should get the same y, whether it's positive or negative x. That's what this yellow box is about. Okay? When you plug in a negative x, you get the same y. Okay? Now, let's go ahead and put that to the test here. By the way, f of x is the same thing as y. Okay, is the same thing as y. All right, so watch this. So let's look right over here. I'll actually just copy it right here. Whoops. Now, so I'm going to go ahead. I'm going to plug in. I want to know, again, if you plug in negative x, you should get the same y. So remember, this is the same thing as y. Okay, this is what we want to verify, that if we plug in negative x, you get y. This is, if I turn this statement into a sentence, if I turn this math equation to sense, it just says, if you plug in negative x, you get y. Okay, that's all it's saying. All right, now let's go ahead and try that. Okay, so watch this. I'm going to plug in negative x into this equation here. Okay, I'm going to plug in negative x into that equation. Okay, and that's what we got. And what's negative x times negative x? Is the same thing as x squared. Okay, so basically this becomes that. Okay, that becomes that. Remember, we're plugging in negative x into this equation here. Okay, and that's how I got this here. Okay, that's how I got this here, right there. Okay, and then once you plug it in, again, negative x squared is x squared, and then now you get x squared minus 3, which matches. Okay, look at the blue highlights. Okay, look at blue highlights. They match. Okay, they match. And if you get a match, okay, that means it's an even function. Okay, that means it's an even function because it matches. Okay. All right, now let's look at odd functions. Okay, this is the one I really want you to pay attention to. Okay, so here's an odd function. Okay, let's look at this guy. Okay, let's look at this guy right here. By the way, as a side note, okay, I gave a generic example of x squared here, okay, in the beginning, and then I I know I might have confused you guys that I somehow bounced to example A. Okay, I did this. And I should have said that we're doing example A here, because it might have confused you guys that I just somehow went from x squared to x squared minus 3. I forgot to say that I was doing example A here. I was verifying algebraically that it is an even function. Okay, or I was verifying algebraically whether it was odd, even, or neither. So I plug in negative x, it matched. Okay, so it's even. Okay, all right. Now let's go to an odd function here. Let's verify an odd function here. So, okay. Now, so here's an example of an odd function. I'm on example C right now. Okay, I'm on example C. So let's look at example C. Now we're going to start always, so if we go to odd functions, okay, the key point is that as opposed to even functions where you plug in a negative x, you get the same y. So even function looks like this, where you plug in a negative x, you get the same exact y. Here, if you plug in, let's look at this coordinate here. This is 2, 4. And this is negative 2, negative 4. Here, if you plug in a negative x, you should get a negative y. Okay, if you plug in a negative x, you should get a negative y. Okay, that's the key point. When you plug in a negative x, you should get a negative y. Okay, so let's go ahead here. Let me go ahead and copy and paste this. Here's an example of an odd function. Okay, now let's go ahead and plug in a negative x. Okay, so here is example C. I copied it. Okay, we're going to plug in a negative x wherever we see an x. Okay, and I'm going to plug in a negative x anywhere you see an x. Now, a negative, so that's how they got this right here. Okay, that's how they got this. It's from here. Okay, now, negative x times negative x times negative x gives you negative x cubed. Just like negative 5 times negative 5 times negative 5 gives you negative 125. Okay, that doesn't change. Negative x times negative x gives you positive x squared. Okay, just like negative 5 times negative 5 gives you positive 25. Okay, so all I'm saying is that the blue highlight here became the blue highlight there. And by the way, folks, I know this example is going on for a little longer than intended. I have to, because we're doing distance learning, I have to explain this in a longer way because I'm limited in my tools that I can use. Okay, but hopefully you're understanding this. If not, you'll understand it through practice. Okay, and I'll be here to guide you. Okay, so back to what we were saying is that negative x squared, negative x times negative x gives you positive x squared. Okay, we're almost done with this example, by the way. Okay, now watch this. Now check this out. Okay, this doesn't quite match with the original equation. Okay, let me copy and paste the original equation again. Here's the original equation. Okay, this right here, this green does not match this green. Okay, because look, this has a negative x cubed, this has a positive x cubed. Okay, something's up here. Okay, so we cannot say it's even because it does not match. Okay, it does not match. So even is off the table. So it can either be odd or neither. Okay, it can be odd or neither. Okay, so let's try doing this. Let's try right here. I'm looking at this yellow box. We're pretty much done. if the function doesn't match, try to isolate or GCF a negative from the function. Okay, so I'm going to do something very simple. Okay, so again, if it matches, you're good, it's even. If it doesn't match, then take out that negative sign. Okay, so watch this. I'm going to take out the negative sign, minus, I'm going to put this negative to the side here. And then we get x cubed over 4 minus x squared. Okay, and now this matches. Okay, now this green matches. Okay, this green, except for the minus, matches that. Okay, and when you have a match, okay, when you have a match with the original equation and you have a minus sign in front of it, then it's odd. Okay, then it's odd. Okay, so again, let me repeat that. If you have a match here, if you have a match for everything but the minus sign on the left, just like in this case, then it's odd. Okay, if it's a perfect match, okay, and no minus sign on the left, it's even. Okay, but in this case, it's a perfect. It's not. It's an almost match. This matches. Okay, here, but then there's a minus sign in front, and so it is odd. Okay, because remember, anytime for odd, anytime you plug in a negative x, you should get a negative y. Okay, anytime you plug in a negative x, you should get a negative y. Okay, and remember, this whole thing is h of x, which is the same thing as y. So this whole thing is basically a negative y. Okay, anytime you plug in negative x, you should get negative y. Okay, last thing. Okay, I know this is, again, longer than my usual lessons. Okay, let's pretend this said 4 plus x squared. Okay, now this is not a match. This is not a match. Okay, this is not a match, and there is a negative sign outside. Okay, in that case, it's neither. In this case, it's neither. Okay, let's say it said, x squared minus, instead of 4 minus x squared, let's say it said x squared minus 4 instead. Okay, let's say a problem looked like this. Okay, this would also be neither, because we don't have a perfect match inside the parentheses. We don't have a perfect match, and there's a negative sign. If there's a negative sign in front, then we need to have a perfect match in the parentheses for it to be odd. But because you have a negative sign in front and it's not a perfect match here, it would be neither. Okay? All right, folks. I'm going to be here helping you guys out, because I know that was a little longer than usual. Whoops.